Having just finished absolute value equations, we are now ready to tackle absolute value inequalities. Which work very similarly to the equations, so we'll start off with what we know. If we were to be given absolute value of x is greater than or equal to 7, say, there are certain numbers that will work here. Before figuring out what we're doing, let's look and see what numbers will actually work. We could have a 8, a 9, a 10, 11, 12, 13, and on up. But also there's another set of numbers, and if we look at them in the number line here, there's another set of numbers that would work. Here's 0, here's 7, here's -7 right there. We know that everything bigger than 7 obviously is going to work. But it turns out that these numbers over here, when you make these guys positive, you flip them up that direction over there, and they end up being bigger than 7 as well. So here's another one. If we have something like absolute value of t greater than or equal to 5, then we have two sets, distinct sets of numbers that work. There's 5 and there's -5. So certainly all of these guys will work. But these guys right here, -6, -7, -8, because of this absolute value turning them positive, they will also work and solve the inequality. And so we get, whenever these absolute values are greater than a certain number, remember absolute value came from distance. So this absolute value, this distance being bigger than 5, we're looking at all numbers that are further than 5 away from our 0 right here in the middle. So we get this solution. We break it up, instead of just breaking it up into two equations like we did with the absolute value equations, it'll break up into two inequalities. The one looks exactly the same. The other one, when you have the negative, it flips direction. So you have this sort of a thing going on. Now I'm going to do these very similar over here. We're going to have absolute value of x is less than 7. See how that changed when we went from a greater than to a less than symbol. Now the numbers that'll work, if here's 0 and there's 7 and there's -7, less than 7 usually starts like this. So we get the idea: 6, 5, 4, 3, 2, 1, 0. They all work in here because they're already positive. And of course their opposites work in there too. Now as soon as we get down here to -7, we don't work anymore. If we start sticking in -8, -9, -10, you stick them into the absolute value turns them positive, and now it no longer is smaller than 7. So again, we see absolute value representing distance. We're saying distance is smaller than 7 from 0. Well, you can kind of see what's going on here, that this is now on a leash. It's trapped. It's stuck in between 7, -7. And what has really happened is it's split into two things. An x is less than a 7, and an x is greater than a -7. And these two things are now connected with and. So this is the preferred way of writing that compound inequality, with an and, that they join together like that. Let's do this other one down here, very similar. Absolute value of t less than or equal to 5, and t is trapped. Since the absolute values can do it, we're going to break it up into the two inequalities, but we get less than or equal to 5 and greater than or equal to -5 at the same time. If you were to try to do that over here, you'll notice how funny it would look to have t greater than or equal to 5 and less than or equal to -5. You have -5 bigger than 5. So that will, if you ever get confused as to which ones you can write like this and which ones you can write like this, that will be sure to help you. So you can see here on the graph, there's 0, there's 5, and there's -5. And we start right there on 5 and go down to -5, and it's good. Interval notation looks like this. The interval from -5 up to 5. So let's try a couple of them. 3x plus 8 is greater than or equal to 7. This is going to split up into two equations. You can kind of tell because I could start sticking a million or a billion or negative a million, negative a billion, and when you make a positive, you're definitely going to be bigger than 7. So we're going to be shooting off, our answers are going to be shooting off to infinity in both directions. So let's write both of those down. Where 3x plus 8, if it is less than negative 7, less than or equal to negative 7, we're going to get an answer here. So if this whole thing turns out to be negative 8, negative 9, negative 10, or negative 50 billion, when you make it positive, because of the absolute values, it will make it bigger than 7. So that'll give us answers. The next one, 3x plus 8 greater than or equal to 7, just like it's written. Solve these guys. 3x less than or equal to negative 15. X is less than or equal to negative 5. Where 3x is greater than or equal to negative 1. X is greater than or equal to negative 1/3. No switching of the sign because we did not divide by a negative number. And this is an OR statement because the numbers can be negative 1/3, negative 5. The numbers can be down in this area here or up in this area here, and that's a union. So set notation, graph, and interval from negative infinity up to negative 5, union negative 1/3 to infinity. And we'll look at one very similar to that. We'll go 3x plus 8 less than 7. Now this one, the absolute value is contained. It's like kept in on a leash. You can't ever get bigger than 7 once you take these absolute values. So that means you start sticking a million or a billion or a zillion, like this guy shoots off to, and 3 million, when you make it positive, is it going to be smaller than 7? No. What about negative 3 million? When you make it positive? No. So this is, you can kind of sense that it's going to be trapped here, and so it's going to make a compound inequality. 3x plus 8 is less than 7, and 3x plus 8 is greater than negative 7 at the same time. So here we have this compound inequality that we can solve, and if we looked at just this half right here, we would subtract 8, subtract 8. Well, if we looked at just this half here, we would subtract 8, subtract 8. So if we subtract from all three portions of this compound inequality, we still maintain that compound inequality. So we have a negative 15 less than 3x less than negative 1. Now we're going to do a very similar thing with the dividing. Divide by 3, divide by 3, divide by 3, and we are left with x less than negative 1/3 greater than negative 5. You'll notice on the graph here, 0, we still have the negative 1/3 and still have the negative 5, but now it says we are trapped in between them. X is greater than the negative 5 and less than the negative 1/3. So we're stuck right in there, which makes sense with what the absolute value of this is going to be trapped. So here's this. And these are the numbers that when you times them by 3 and add 8, they will be right in between negative 7 and 7. So the interval notation will be negative 5 to negative 1/3. And there we go. Couple of ones that we're going to do here that I'm going to show you. 3x plus 8 greater than or equal to a negative 7. Now back when we did equations, we said, hey, we don't even have to do anything when we have a negative. We automatically have no solution. Well, that's not entirely true here. If we were trying to make this guy equal to negative 7, certainly we can never make a positive number equal a negative number. So that was true back with equations. Absolute values never equal to negative number, and that's still true now. However, this is a positive number, which means it's always bigger than or equal to 0, which means it is bigger than or equal to negative 7. These two will never equal each other, but this guy is always bigger. So the solutions to this, if we mark 0 here, we could mark any number. The solutions are everything So we could write it like this. The set of all x such that x is a real number. It's on this real line. Everything works. We will always have a positive greater than a negative. So let's try one very similar. Absolute value of 3x plus 8 less than negative 7. Now here, this is positive. It will never equal a negative 7. It's always bigger than a negative 7. It is never smaller than a negative 7. So this is no solution. If it's asked in set notation like this, there is a way to write a set that has nothing, and it is a circle with a line through it. And that is the way they write the empty set. That's what that thing is. And that's absolute value inequalities.